Map legends and scales. So map legends. So maps contain man-made and natural features. So a lot of features are shown on maps, including, again, man-made features, natural features, etc. These are represented by symbols such as black dotted lines for trails, or unpaved roads in this case, solid red lines for highways, like interstate highways, small black squares and rectangles for buildings. Sometimes it's not just a square, it's actually the shape of the building if the building is big enough to the map scale. So a legend really, or a map legend, explains what these symbols mean on a specific map. So for our example over here, we have this red line with the symbol with the number in it, the little shield. For interstates, you have a black line with a different type of shield in it and a number. For U.S. highways, state highways have a circle with the number. Scenic byway in this case is yellow with a black dashed line. You got unpaved roads, you got railroads, rivers, tunnels, lakes or reservoirs, typically outlined in blue with a blue center, airports, national parks, marinas, etc. So you have all these different features on a map and more. And sometimes there's also color coding to show what different land uses are and things like that. So is it a forest versus a farm field or something like that? So map scales. So a map scale is the ratio between distances on a map and the actual distances on the Earth's surface. We have verbal scales, which express distance as a statement. So typically this might be written out as an equation. So 1 centimeter is equal to 1 kilometer, or again, 1 centimeter is equal to 1 kilometer, which means 1 centimeter on the map is 1 kilometer on the ground. You have graphical scales or graphic scales, which consist really of a line that represents a certain distance, and you usually divide it up into other distances. So it may be a line that says this is 1 mile, and it may be divided in half to show that's a half mile, or it may be very common is like a kilometer divided up into 10 bars to show like every 100 meters. Fractional scales represent distance as a ratio. So a 1 to 63,500 ratio means that 1 of any unit on the map is 63,500 of the same unit on the ground. So 1 inch on the map is 63,500 inches on the ground. 1 centimeter on the map, same thing. 1 paperclip on the map is the same thing, 63,500 paperclips on the ground. So that's a fractional scale. Now out of these, if you're changing the size of the map, like if you're making copies and making them bigger, making them smaller, graphical scale is really the only one that stays consistent. The verbal scale and the fractional scale are designed to go with the map the size that it's originally printed. Because if I shrink the map by half, then this fractional scale doesn't work. Same with the verbal scale. The graphical scale would, because it actually is printed on the map and it will change sizes with the map. So some examples here. So a fractional scale at the top here, 1 to 24,000. That's actually a very common scale for a lot of topographic maps. A lot of times in the scale, you're also given a contour interval. So there's our contour interval for 100 feet if it's a topographic map. Different graphical scales. Again, you've got 1 mile on this side, and you've got it divided up into tenths of a mile on this side. Same with the kilometer. You got a kilometer over here, and then you got tenths of a kilometer over here. And then this is divided up just by every 1,000 feet on this side, on this one. And then we have a verbal scale. 1 inch is equal to 24,000 inches, or 1 inch is equal to 2,000 feet on the map. Now, small scale versus large scale. You may have heard this for models or things like that, like if you build scale models of cars or airplanes or railroads or anything like that. Well, the same thing applies to maps, but it's kind of counterintuitive. So a small scale map usually has a very large ratio. So 1 to 1 million, for example, is a small scale map. This covers a very large area. And the whole idea is it's small scale because everything on here is kind of tiny in comparison to a large scale map. Just like a small scale railroad would be something that would be a lot smaller than, a large scale railroad. Again, this is drawn 1 to 1/1,000,000th of their actual size. So everything is drawn very small. So this covers a very large area. So if you have a small scale map, it covers a very large area because everything is closer together on the map and smaller. A large scale map is the opposite. It has a small ratio, 1 to 24,000, and maybe even like 1 to 12,000 or something like that. These cover smaller areas, like maybe just a city or a county. And these are drawn, in this case, if it's a 1 to 24,000 map, it's drawn 1/24,000th the actual size. This is actually 1/25th, 1 to 25,000 for this map, and this is actually 1 to 4,500,000 for this map. So this is a very small scale map, very large scale map. And then finding north. So the compass rose shows cardinal directions. So you get north, south, east, and west. North is usually at the top of the map. Okay, so north is usually up on the map. Does not apply to GPS navigation. Usually your track is up, which basically means it's going to have your car going forward and the map rotates around the car. So be careful if you're using GPS navigation, because a lot of times it does not set to where north is up. And there's something called magnetic declination, which is the angle between the geographic North Pole and where a compass points, or the magnetic North Pole. Why do you need this? Because if you're using the compass to find anything on a map, the geographic North Pole is kind of what we think of as actual north. But the magnetic North Pole is what we have something to find. We have a compass to find that. So the magnetic North Pole does tend to wander. It actually will move around. And it's really different depending on the location. So depending on where you are on the Earth's surface, the declination will be different. So what you have is you have a little magnetic declination on some maps that will show you how to correct for that. So if your compass is pointing what you think is north, where you turn the little dial, a lot of compasses have a dial that'll turn, so you could turn that a little bit so that it actually is pointing true north for you.